Hi everyone, welcome back to GA Online Teaching. I know it's been a while and things have just been so hectic thus far, right? I want to wish everyone the best, especially in this testing, trying time when learners, parents and teachers are full of anxiety. I want to send you hope and make sure that you stay safe, wear your mask as well as sanitize. Okay, today we're going to do term 3 work and we are going to combine grade 9 and grade 10 lessons together because it's one topic, and that is the topic of congruency. Now when I take a look at the definition of congruency, I look at what do they want from me. Most of the time when they ask you if two triangles are congruent, they want you to compare the two to find out which angles or which sides are the same. Remember, you only need two things in order to prove that the two triangles are congruent to one another. Now congruency means that they are the same shape, obviously, triangles with the same sides, with the same angles. The only difference is it might be rotated. Now a lot of questions will arise. Firstly, how do I have two triangles and if I put them together, how is it known as one diagram? And that is exactly what it says. I have two triangles, 1 and 2. If I put them together, it makes one triangle. One diagram. So therefore, in these two triangles, I'm going to prove for three things. Right? The very first rule that I'm going to do is the side rule. So prove that triangle ABD is congruent to BCD. Right? All I have to do is prove three things. Right? So the very first one is, what tells me that angles are equal to one another? That little line over there. If that has 1 and that has 1, it tells me that those two are exactly the same in length, right? So therefore, I can say AB is equal to BC. How did I know that that is equal to each other? That's the reason. Remember, we're busy with geometry, so we need to have a reason. And the easiest reason is, I told you that these two are equal to, or the questioner told you. In other words, you are given that those two are equal to one another. So your reason for saying that is nothing other than it was given to you. Right, that's one more. The next one, I see two lines, meaning that AD is equal to CD. Now be careful of saying DC. Notice the reason why I said CD is because in my second triangle, the letter C comes before the letter D. So you always follow that rule over there. And the last one is BG is congruent to itself, is equal to itself. In other words, it is common. Please forgive me, I forgot to write the reason given over here. Now, why is that common? Because the line D, if I shift the two triangles apart and I bring them together, you'll find that BD is exactly the same in one triangle and exactly to the second triangle. In other words, the line BD is shared between the two triangles, i.e., the common theme in these two triangles is BD. That line over there. So your reason is common, right? So that's three reasons, three statements. Boom, I'm done. I prove that it is congruent to one another. Now, the last point is you need to make a final statement. You need to say, therefore, because I proved that these two triangles are the same, using only three reasons. How? What? I say, therefore, triangle. I make a final statement. BD is congruent to triangle BCD. How did I prove it? In other words, what did I prove? I proved that the three sides of the one triangle is equal to the three sides of the second triangle. Therefore, my rule would be the side rule. In other words, I prove that three sides are equal to one another. Okay, Now we move on to our second example, which is a grade 10 example, also interesting for a grade 9 example. I'm still going to use the side rule. Alright, so ABCD is a palm, in other words it's a parallelogram, and immediately when you see a parallelogram, things have to occur in your mind. Number one, you need to know its properties. Number two, you need to know when I'm busy with its properties, one of them says the lines going up and the lines going sideways are parallel, and parallel lines brings what into place? It brings your fun angles. And remember, we're not going to use fun angles today because we're still busy with the side rule. Okay, the first thing is prove that triangle AEB is congruent to triangle DFC. And look at the direction A to E, then to B. Direction D to F, then to C. Alright, so remember I need to prove that three sides are equal to one another. So the first one is one line over there, which is AE. One line over there is equal to DF. And how do I know that? Because it is given to me. The next one, two lines, BE, or rather, excuse me, EB, because look at the direction, EB is equal to this side over here, CF or FC. The direction F comes first, so therefore FC. How do I know that? Because it's given to me. They both have two lines. And now we're looking for those two sides that are the same. Now if I look closely at the definition says it's a parallelogram. So what did I tell you? That the opposite sides of a parallelogram are equal to. In other words, this side is equal to that side over there. And notice it's the sides of the parallelogram as well as the sides of the triangles that I'm finding the congruency of. So therefore APB is congruent to the side over here, and that is DC. Now, is that given to me? No, it's not. I have to calculate it, right? Using what? Using geometry, using the properties of a palm, and the property that I use is that opposite sides in a palm are equal. So therefore I prove that three sides of the one triangle is equal to three sides of the second triangle. Therefore I ended off triangle AEB is congruent to triangle DFC because of the side rule. Remember the first example, I am going to find the grade 9 one, the second example, the grade 10 example. And every day I will first do side. The next lesson will be side, angle, side. Until next time, please don't forget to like, share and subscribe to GA Online Teaching.